Okay, so welcome back. And so today we're going to talk about completing the square again. And so what we're going to do is we're going to talk about graphing an equation, a quadratic equation, a quadratic function, graphing it using that form where we can use transformations. But one of the things we can do with that form that I showed in the last video is that it gives us an easy way to use transformations to graph things, okay? But we can also glean real important characteristics, as we're going to see right now. So in this form, so we have a times the quantity x minus h squared plus k. Now hk, if it's in this form, again, subtraction, addition, if it's in this form, then the vertex is hk. Right, just like when we talked about circles, the center radius form of a circle. If it's in that form, then it's easy to pick the radius and the center of the circle. So likewise, in this form, for quadratic equations, it's very easy to pick out the vertex, which is hk, and the axis symmetry, which always goes through the x value, right? Because it is a vertical line. So it's always of the form x equals a, or in this case, h. Okay? So the axis symmetry is always going to be x equals h, and the vertex is always hk when you're looking at this form. Okay, so it's easy to pick these features out. Now, what if you don't have it in this form? What if you're given it into the standard form and we want to graph this thing? Well, we don't want to plot points, right? So we could, but again, I'm not going to ask you to do that. So what we need to do is if we can put it into this form here, then we can easily find the axis of symmetry, find the vertex, and we can easily find points on either side of the axis of symmetry to plot. For example, the Y-intercept would be one. Because if we're going to plot the Y-intercept of the graph, then using the axis of symmetry, we can easily find a third point. Okay, but we'll talk about that later. Okay, so let's see what we can do here. So now, how do we get it into this form? Well, that's where completing the square comes in again. So again, this is another time where you need to know how to complete the square. We saw it earlier, okay, when we're dealing with review, right? Completing the square to solve an equation, a quadratic equation. We also saw completing the square in dealing with circles, equations of circles, going from general form to center radius form, and now we're seeing it again with quadratics. Okay, so we're going to complete the square, but here's the thing. We don't have any equal sign here. This is not an equation. So we cannot use the method where we move the constant to the other side of the equal sign because there is no equal sign. So we're going to have to keep everything together. So this is where we're going to have to add and subtract the same amount. So now what I'm going to do is, again, I want to complete the square on this thing because as it stands right now, it's not a perfect square. Okay? Because there's no factors of 7 that will give me negative 6 when I add them. Okay? So, and since this is negative, right? And this is positive, which means, well, actually, no. This one does work. Okay, they gave me an example that does work. No, it doesn't. Wait, 2 times 7. No, it doesn't work. No, it doesn't work. So this is positive. This is negative. And so if this is positive, that means they have to be the same sign, right? Either both negative or both positive. Well, this is negative, which means they both have to be negative. There's no factors of 7 that's going to add up to negative 6, right? You got the only 2 factors is negative 1 and negative 7, right? And that does not give us a negative 6, so it won't work. So now, what I'm going to do is I'm going to ignore the 7. And I'm just going to concentrate on these two. So now what I'm going to do is I'm going to do completing the square on this piece. So I'm going to put parentheses here to separate these two terms from this one. So I'm going to do x squared minus 6x. Now, plus what? What do I have to add? Well, remember the method. I'm going to divide this by 2 and square it. So negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So I'm going to add 9. But if I add 9, then I also have to subtract 9 so that the net effect is 0. And then I'm going to add the 7 on here. So notice, just notice something. I didn't change anything, right? I just added 0, right? So this piece here is the same as this piece. I just added this so that I can have a completed square here. Okay, so now this piece here is the perfect square. So now all I have to do is divide this by 2, and that's going to give me the number I need to have. So this is going to simplify to x minus 3 quantity squared. And now I have the minus 9, right? But then I also have this plus 7. And now I can combine these two because I can drop the parentheses now once I simplify this. And so now this becomes x plus 3 quantity squared, and I have this minus 9, and I have this plus 7. And so my final expression becomes what? X minus 3 squared minus 2. And so now this is my function. And so now immediately I know important information. I know that the vertex is what? Well, let's go back. Negative to subtraction. So my h is 3. So the vertex, is going to be located what? 3. And what about this one? Well, this is plus, so that means this is a plus negative 2, right? So if I make this into a plus, then that becomes a negative 2. So this is 3 comma negative 2 is my vertex, which means the axis of symmetry is what? Is going to be x equals 3. And so now let's graph it. So we know the vertex has to be at 3, negative 2. So 3, negative 2. So it's got to be right there. And the axis of symmetry goes through that point, right? So x equals 3. So it's going to be like that. And so from here, I know I can graph each point because I know it's got to be the next point over. So if this point here is the vertex, okay, then I know the next point, right? Because remember the basic function. It goes through 0, 0, 1, 1, and negative 1, 1. So if my vertex is here, then based on this, there's no, a is 1. So there's no vertical stretching or shrinking going on. So I know if this goes to here, then the next 2 points on either side is going to be at what? 4, negative 1. Oops. And at 2, negative 1. And so I know it looks like that. And that's it. And I think that's all they wanted to do. Let's see here. Right. So here you can find the y-intercept, right? So the y-intercept is where x is equal to 0, right? So this is easy. So if this is 0, that means I get negative 3 squared, which is 9. 9 minus 2 is 7. So I know the y-intercept is going to be up here at 0, 7. And so I can plot the x-intercept. Well, guess what? If the intercept, the y-intercept is up here, at 7, right? So if it crosses here, so let's extend this out. Then guess what? If I know the x's symmetry is at x equals 3, and I know this is 3 units from the y-intercept, well, guess what? The other point that's on the other side of this is going to be what? 3 units away. So that's going to be at 6. So it'll be here at 6, right? And it's going to be up at 7 as well. And so I know that there has to be another point at what? At 6, 7. Because this one is at 0, 7. And so the axis symmetry says if I'm 4 units away here, then the other point has to be 4 units away on the other side. And so I know that this also extends and must go through that point. So you can use symmetry that way too. You can find the y-intercept and use the axis symmetry to find another point. So you can plot points very quickly and very easily using this method. Okay? And that's it. So next time, now again, so this example, just to go back there, this example is based on that a is equal to 1. So the leading coefficient here, the leading a value is 1. Okay, so what we're going to do is next time we'll do an example of where this is not equal to 1. Okay, what happens if this is not equal to 1? Okay, obviously it can't be 0, but what if it's not equal to 1? Then it's just a little bit more involved. But again, not very difficult at all. But again, you just have to be careful at one step. So we'll do that next time.